Hello class 8 students. So today I am going to start chapter number 11, that is force and pressure. And this chapter was included in your first term examination. Due to the sudden lockdown we could not finish this chapter. So today I will be discussing this chapter, that is force and pressure, that was included in your first term course. Okay. So in this video, in the first part I will be discussing about the force, and in the second part I will be discussing about pressure. Okay. In the first part I will be discussing about the definition of force, effects of force, contact and non-contact forces, and in the next part I will be discussing about pressure. Okay. So let's start with the first part. Now, when you hear the word force, when you hear the word force, what we actually think is that force is a physical energy that can be seen or felt. Force is a push or a pull on an object. A force happens when two objects they interact with each other. That is, when one object it does something to the other object. When the interaction stops, the force stops too. Okay. Now, there are some forces. In which two or more objects they interact. Now, and there may be two or more forces acting on a particular object. The total of all forces applied to an object is called as net force. Okay, it is called as net force. For example, you see in activity 11.2, forces in the same direction and in the opposite direction. You see more than two forces are applied to an object. Okay. Now, in this experiment, I will be discussing about the net force. In this figure, you can see, in figure number A, you can see a boy and a girl. They are pushing a box. They are pushing a box, that is, they are applying force on a box in the same direction. That is, to the left they are applying their force. And in the second pic, you can see that one boy and one girl, they are pushing the box, means they are applying the force on the same object but in the opposite direction. The girl is pushing the box towards right, and the boy is trying to push the box towards left. Okay. So, what we will see in the first figure is that when the boy and a girl was pushing the box, equal forces were applying on the box, and that too in the same direction. So, since the boy and a girl was pushing the box in the same direction, the object will also move in that direction in which they are applying the force, isn't it? The box will move when both of them are pushing in the same direction. And forces acting in the same direction also adds up, isn't it? While in the second video, in the second pic, you will see that when two persons are applying force on the box, it was not easy to move the box when the two of them were pushing in the opposite direction, one in the left side and another in the right side. The box will not move at all if both of them were pushing in the opposite direction and with the same force. And the resultant force in this case will be 0. The resultant force or the net force in this case will be 0. Now, in this case, what will be the net force? The net force which is in the same direction. Same forces are applying by both the persons, so we will sum the two forces in the same direction. But if the forces are in the opposite direction, then we will have to then there will be difference between the two forces acting in the opposite direction. If they are in the same direction, then we will have to sum up the two forces, and if they are in the opposite direction, then we have to make the difference between the two forces. This is all about net force. But if the force is equal between the two persons, and the object is not moving in either ways, So the net force will be 0 here. Okay. So this was all about net force. Now we will come to the effects of force. Effects of force are on a stationary object, on a moving object, and in fact on the shape of objects. First, which is there in your book, is effects of force on stationary objects. Stationary objects are those objects in which the substances or objects are at rest. When force is applied on a stationary object, the object tends to move in the direction in which the force is applied. For example, applying force on a stationary tennis ball will make it continue its motion in the direction of applied force. Next is your effect of force on a moving object. Now, force needs to be applied on a moving object either to stop it or to slow it down. For example, the moving ball can be stopped by applying external force. Okay. The direction of a moving object can be changed by applying the force on that object. For example, the direction of the moving football can be changed by applying force such that the direction is changed. Okay. So, force on a moving object can even change the direction. It can even make an object move. If it is at rest, it can also make it move. So these are some of the effects of force on a moving object. Effects of force on a shape. If you consider a rod, which is circular in shape, by hammering the rod which is applying on external force, the rod can be turned into a flat sheet. So this is one of the effect of force on a shape. Now there are two types of force. First is contact force, and another one is non-contact force. Contact force is any force that requires contact to occur. Contact forces are basically those forces that act between the two objects that are physically touching each other. For example, muscular force or frictional force. Okay. So muscular force is a type of force wherein we use our physical strength to change the state of motion of an object, and frictional force, it refers to the force generated by two surfaces that contracts and slide against each other. Okay, this is all about muscular and frictional force. Next comes is your non-contact force. Non-contact force, it is a force which acts on an object without coming physically in contact with it. Okay, the most familiar non-contact force is gravity, which confers weight. In contrast, a contact force is a force applied to an object by another body that is in contact with it. Okay, now non-contact force such as gravitational force, magnetic and electrostatic force. Okay, so first we will come to the gravitational force. The most familiar non-contact force is gravity, which confers weight. Okay. Now, when two objects in the universe, they attract each other by a force called as gravitation. By a force called as gravitational force. Now, gravitation is a force of attraction between all masses in the universe. Whatever substances, whatever masses or matters are present in the universe, it is a force of attraction. They attract each other, isn't it? So, this is the force of gravitation, especially the attraction of Earth's mass for bodies near its surface. And gravity is actually what? Force of gravity. Gravity is actually the special case of gravitation in which one of the two bodies happens to be in the earth. The force of gravitation exerted by the earth is called as gravity. Okay. Next comes is your weight. Weight is a force which is equal to the gravitational pull exerted by any heavenly body. Weight on a body can be zero during the free fall. When a fruit falls down from a tree, what happens? It is the fall is due to the free fall. It is due to the gravity. That's why the gravity in that case, or the weight of the body in that case, will be zero. Okay. Now, magnetic force. Next comes is your magnetic force. Magnetic force is a force that attracts. Magnetic force is a force that attracts certain metal objects towards a magnet. Okay. in magnetic force, like poles like north and south. Suppose one pole is either north and another pole, say suppose it is south, they will repel each other. And unlike poles like north south, they attract each other. Suppose you can see in this figure, if I tell you, suppose this is the magnet. This is the magnet given in the figure. Suppose the two ends of the magnet is, say suppose north and south. So in that case, what will happen? They will repel each other. They will not come in contact. They will repel each other. Suppose this end of the magnet is north, and the right hand side end of the magnet, say suppose it is south pole, and they will attract each other. Okay, they will attract each other. If you bring another magnet in contact with this bar magnet, and suppose this end of the magnet is north, and another magnet that you have bring, suppose one of the end of that another magnet is south pole, then what will happen? They will attract each other. Okay, so this was all about magnetic field or magnetic force. Electrostatic force is what? Electrostatic force is a kind of force which is exerted by the electrically charged object. Electrically charged object, that is a force exerted by a charged body on another charged or uncharged body. This is all about electrostatic force. Okay. Now comes your unit of force. The SI unit of force is Newton. Okay. And the non-SI unit of force is kilogram force. It is also used as a unit of force. 1 kgf is a force exerted on 1 kilogram of mass by gravitational field of 1 standard gravity, and so is equal to 9.8 Newton or 10 Newton. Okay, so this was all about units of force. Then you have gravitational force, then force of gravity, effects of force. So this is one of the most important topic of your chapter, that is force and pressure. So it is necessary to read the chapter along with the question answers that I have given you long back. You read it and read the chapters. Okay, and in the next video I will discuss something about pressure. Okay.